In this video lesson, we will be taking a look at writing system of equations from a table. In this one example, it says the following joined table represents a system of equations. Write a system of equations that is represented by the following table. So here we have a table. It's a little bit different than what we're used to seeing. This table represents two different equations. So think about it as two separate tables that we're used to seeing. So let's just cover up this one here. So this would be the X and Y outputs, or the input and the output for the first table. So we have a 1, 6, a 2, 10, a 3, 14. And then we also have the input of 1 with an output of -6, an input of 2 with an output of -8, an input of 3 with an output of -10. So what we're going to need to do is write both equations that's represented by these two different tables that are joined together as one table. All right, and of course we're going to write this in y equals mx plus b form. All right, so that means we're going to need to be able to find the slope and determine the b as well. So this is going to be quite a bit of a problem. It's going to take a little bit of time, but we most certainly can do it. All right, so let's get started. So the first thing we need to do is work with the first table. All right, so we have our inputs of 1, 6, 2, 10, and 3, 14. We need to find the slope. So we're going to find the change in y over the change in x. So to find the slope, again, just to remind you, that's the change in y over the change in x. You also know it as y2 minus y1 over x2 minus x1. But if we just look at the change here from 6 to 10, that's a change of +4. And if we look at the change from 1 to 2, well, that's just a change of 1. So our slope is 4. All right, for that equation. Now we want to write our equation y equals mx plus b. But we know that the m was 4, so we can go ahead and just replace that with 4. So let's call it y equals 4x plus b. All right, but now we're going to plug in the one of these ordered pairs. We'll just use 1, 6, and we'll plug it in here. So where x, we're going to replace that with a 1 and y with a 6. So now we're going to say 6 equals 4 times the 1 plus b. Well, we know that this is 6 equals, and then 4 times 1 is 4. We add b. We're trying to determine b. So we want to get b all by itself, so we're going to have to subtract 4. Now we know that b is equal to 2. So we can rewrite our equation where y equals 4x plus 2. That is one of our equations. This equation is for this table right here. Okay? All right. Okay, so I've taken that work and I've just kind of shrunk it down over here. So now I'm going to work with the second table, okay? So our change in x is not going to change, but again, we're trying to find slope. So just as a reminder, our slope is equal to the change in y over the change in x, okay? Here, our change in y, if we're going from -6 to -8, it's actually a change of -2. All right? If you did -6, yeah, the difference in -6 and -8 is -2. And then, of course, over here, the change in 1 and 2 stays the same. That's 1. So our slope is -2. All right? Now, again, our equation, we're going to write it in y equals mx plus b form. So that's -2x plus b. All we've done is plug in the slope. But now we're going to use an ordered pair. We can go ahead and stick with 1. That's probably the easiest one to work with. 1 and -6. So I'm going to replace x with 1 and y with -6. All right, so when we do that, we have -6 equals, and then we have -2 times our 1. And then, of course, we have plus b. Okay, now we just need to go ahead and solve this. This is -6 equals -2 plus b. And we are trying to solve for b, so we need to isolate it. So the inverse of subtracting 2 would be to add 2 to both sides. We have to add 2 to this side to cancel it. We add 2 over here. And then when you do -6 plus 2, you get -4. So we know that b equals -4. Well, if that's the case, then we can write our equation as y equals -2x minus 4. And that is our second equation. Okay, so our two equations were y equals 4x plus 2 and y equals -2x minus 4. That is our system of equations that produces this joint table.